Hello everyone and welcome to another video for AP Computer Science. We're going to finish up our discussion on arithmetic and the math libraries in Java, and then we'll move on to the next interesting topic, which will be, and it'll be brief, compound operators and casting between numeric data types. Before we move on to that, I want to discuss one aspect of the math library we didn't really look at, though you may have noticed it if you played around with it or if you saw it in the previous video. And these are constant values in the math library. So the two constant values that exist in the math library in particular are the values for pi and e. Both are very well-known, well-established irrational numbers. They have an infinite number of values or digits after the decimal place. So in the real number, in the world of typical mathematics in the real world, and the set of real numbers, we recognize that there could be an infinite number of digits after the decimal place. We can't represent that on an actual computer with limited RAM. If we gave up all of our RAM for as many digits as possible, then we might have a really, really large number of values, but that's not particularly helpful. So what Java chooses to do instead is to just max out the number of significant figures possible for those values and then keep those as constants. What does it mean to be constant? In relation to the idea of a variable, which means to change, a constant is a variable that has been set with a particular keyword that disallows the changing or reassigning of the value. So as an example, I can go ahead and print out the value pi from the math library. To access these two constants is very much like accessing the functions of the library, of the math class, like sqrt or square root. We said math dot and then the name. And so since these are functions that have inputs and generate outputs, they have a parentheses and input inside of them. The constants are just single values, so we don't have to necessarily put parentheses afterwards. So we're going to say math dot capital P capital I. And so constants, typically the rule, and we'll see in a moment what we can do, constants typically are all capital letters. And so capital P, capital I, and then if we do the math constant E, it's just going to be a capital E. If I go ahead and print this, we can see the result. I'll give it a moment to compile. And there it is, 3.141592653589793. 17 significant figures if you count it, because that's as accurate as it can be with a double. The reality is that's pretty much more than enough accuracy that you would ever need for almost any application. More digits don't really help that much. Even in super accurate things, 16 numbers after decimal place is a good amount of values for pi and for e. And of course we could change this arbitrarily to e, and if we run it, we'll see the same thing, but it'll be 2.71 and then a bunch of stuff. And there it is. So those constants are very useful to have, and they're specially set up in the math library. But the reality is, in a program that we might create, we might want to make our own constants. Why would we want to make our own constants? Essentially, we might say, well, I'm going to use a particular number a lot in my system. Maybe our system calculates taxes or refers to the sales tax of something in a store, let's say. Right? So for example, maybe in Florida the sales tax is about 7%, and so our program is aimed at selling stuff in Florida, and so we need to always know the sales tax. One option we could do as a programmer is whenever we needed to refer to this percentage, 7%, like for example a multiplication or something like that, we could just multiply by 0.07. But let's say we did this hundreds of times, and then one day the government makes a change to the tax rate, and now it's 7.5%. As a programmer, we might have to hunt down those hundreds of uses and then change them all to 0.075. And that can be tedious. So instead, if we make a single variable, mark it as constant, meaning it cannot change once it's been set, that means that we can refer to the name or the label of the variable as many times as we like, and the day that we want to change the value from 7% to 7.5%, we change one variable declaration, one assignment, and every reference automatically adjusts. Of course, we would have to recompile our program, but it'd be much easier for the programmer to change one location than change it everywhere that it was referred to. The idea of like loose numbers just floating around that have meaning. So for example, if I had that 0.7 floating around, it's not just a 0.7 because it's a percentage or a tax rate, so we call those magic numbers. If you have magic numbers in your program, you might want to consider changing them to constant variables or variables so that we can easily manage them in the future. So how do we make a constant value? So let's go ahead and put some notes. Constant values in Java cannot be changed in a running program after they have been initialized or assigned, right? So in this example, so then how do we make a constant? Our constant text is the keyword final, our data type, and then our variable name. So variable name, and then equals value. So we'll say value. So this is the typical thing we'll do. Usually, you initialize a variable to a value immediately if you want it to be a constant. Do you have to? No. Technically speaking, you can declare a final variable, a constant, not give it a value, and then at some point in the future assign it, and then once it's been assigned, it cannot change. So, but typically, I'm going to do it in one line. So let's try that. Final, and let's say double. We'll call it tax rate. I'll also point out the standard. Remember, we discussed standards for variable names, and that was camel case. Typical variable names were camel case. Class names, like arithmetic, are capital case. And constants are often called caps or all caps case. And essentially what it means is that every word is capitalized all the way. And then so since they're all caps, we can't use that whole lowercase to uppercase bump to recognize separate words. So we use underscores to separate each word. So this is tax rate all caps. And then we can assign it to 0.07. And so the only thing that's changed is the name, and this is not required. This is, again, a standard. It's a good idea, but it's not forced on you, not by the language, just by professionals, I guess. But the keyword final is what really has the impact. And to prove it, I'm going to attempt to change the value. So I might try to say tax rate equals 0.01%. And it fails. And if I read the error, we get this message, cannot assign a value to a final variable tax rate. And so you might ask, well, why would you do this? Why would a programmer, if they know they don't want to change it, why would they ever write a line that changes it? And that's a pretty reasonable question. And the answer might be, you don't know who's going to code on every system. You might have professionals that have been there for 15 years and then have a new junior programmer that's just joined the team. And they may not realize how important the variable is and how important it is that it doesn't change. And so if it wasn't controlled by the compiler with the final keyword, we would have to trust humans to not either accidentally change it or not maliciously change it, right? So someone could do it on purpose, and that would also be a serious problem. Accidents are not always accidents. And so the keyword final basically says to the compiler, hey, can you keep an eye on this variable and make sure no one changes it? The more work we can offload onto the compiler to validate our work, the safer we are. And that's one of the advantages of a language like Java, that we can just kind of use keywords to force expectations on the compiler. And that can be a very good thing sometimes. And so constants cannot be changed. So I'm going to go and comment this line out, leave it there so we can see it, and just put a note afterwards saying, so constant variables cannot be reassigned. And that's a useful thing to have. So I'm going to stop here in this video, and we're going to move on in the next video to casting values and using random numbers. Those are two pretty interesting concepts that we'll talk about. So I'll see you in the next video.